All right, section 4.5 again today. We're going to play with some more integration by substitution. Today we're going to require you to do just a little bit more thinking. I know I've stretched your brains quite a bit at this point, but we're going to continue to stretch those brains and make you think a little bit more. So here we have the integration of 2x times the quantity of x plus 2 squared dx. As in the past, we've talked about what u should be. U will probably be, if we have a quantity to an exponent, going to be that quantity. So let's go ahead and see what happens. So we have a u equals x plus 2. du then would be dx, wouldn't it? So if I come over to my integrin, that 2 we can't get rid of. The x we can't get rid of. Already seeing a problem, aren't you? X plus 2, that's going to go away. That's going to become our u squared, and then our dx becomes du. So recall that this variable here of integration must be the same as the variables that we have in our integrin. That's an issue because we have this x. But what do we know about this x value? We know this x, there's a relationship between x and u, isn't there? If I subtract 2 off of this equation, I'm going to work up now. So u minus 2 equals x, doesn't it? So I can do the integration of 2 times u minus 2 times u squared du. Now some of you may be asking yourself, well, why didn't we just multiply this here out? Doesn't matter to me if you want to multiply it out, but what's going to happen if maybe this is to the 4th or to the 5th or to the 10th power? Then it becomes very difficult to go ahead and multiply it out. That's why I'm going to show you this here. Here we can go ahead and we can pull this 2 out actually to the outside of the integration, and we can multiply u minus 2 to u squared to get u to the third minus 2u squared du. I now know the integration of these two parts. So I have 2 times the integration of u to the third is u to the 4th over 4. Integration of 2u squared is 2u to the third over 3. And then plus our c value. We can go ahead and replace the u with x plus 2. So we have 2 times x plus 2 to the 4th over 4 minus 2 times x plus 2 to the third over 3 plus c. At this point, we just kind of got to play around with it until we get to an answer that we're given or we want to get to, as multiple choice or if it's in the back of the book or posted online. Kind of depends on where the author of the question stops versus where you're going to stop. So what could we do at this point? So extended response again, we leave it just like this. We're done with it. But multiple choice, you may have to find a common denominator here. So if I found a common denominator, that would be 12, wouldn't it? So I multiply this by a 3, so I get 3 times x plus 2 to the 4th, minus, going to multiply this by 4, so I get an 8 times x plus 2 to the third, again then plus c. Continuing, again, if we wanted to, if we want to get to an answer that's posted, we could factor the numerator. We could take out x plus 2 to the third. So I'd have a 2 times x plus 2 to the third, times, well, times what? We can have a 3 times an x plus 2 minus an 8, don't we? And that's over 12, again, plus c. Finally, we could cancel out the 2 and the 12. That becomes a 6 in our denominator. So we have an x plus 2 to the third times, we can multiply the 3 through, and it would give us 3x plus 6 minus 8. So 3x plus 6 there, minus 8. That would give us a 3x minus 2 plus c. And that could be the function that we started with. So again, extended response, we're going to leave it way up here. We're going to replace those u's with what those x's are, and we're going to call it a done day. Multiple choice, notice how much nicer this answer here looks. Oh, this is over 6, sorry. Over 6. This much looks compared to this answer up here, or even this answer up here. So again, it's kind of up to the person who's writing the question, asking the question, and the question that you want to get to. The biggest thing, though, is being able to find what that u is and that integration. Here in our second example, we have x times the cube root of 1 plus x that we're integrating. So u, again, we could change this 1 plus x to the 1/2 power. Now, or to the 1/3 power. Now it's going to be very difficult and ugly to get this anywhere near being able to be integrated. So I'm going to let my u be that quantity on the inside, which is going to be x plus 1. So du then would be dx. So if I look at my integration, my integrand here, I have x. I don't have an x going out with my dx, so I'm going to go and solve for x up here. So u minus 1 is going to equal x, isn't it? So I get u minus 1 times the quantity, or u to the 1/3. I guess we don't need the quantity anymore, do we? du. So again, that x came from this u minus 1 equals x up here. So we did our substitution. We had to get another substitution. The 1 plus x, that went to u to the 1/3 power, and our dx was equal to our du. We can go ahead and then integrate or multiply, distribute the u to the 1/3 to get it in polynomial looking form. So we get u to the 4/3 minus u to the 1/3 du. This is completely integratable at this point in time. So we have u to the 7/3 divided by 7/3 is going to be multiplied by 3/7. U to the 1/3 is u to the 4/3. Again, divided by 4/3, the same as multiplying by 3/4 plus our c value. We can go and replace our u with x plus 1. So we get 3/7 of x plus 1 to the 7/3 minus 3/4 of x plus 1 to the 4/3 plus c. Again, if you want, we could do some factorization. We could find a common denominator. There's a multitude of things that we could do to be able to get to that answer. Extended response, again, I would leave it just like it is. And I'm going to go on to the next problem to show us how that problem is going to be set up. Here we have x to the 3rd times x squared plus 1 to the 5th dx. So what do I want my u to be? Well, u is going to be that quantity of x squared plus 1. So du is going to be 2x dx. Well, that's interesting because now I've got an x in there. Didn't have the x's before, and I had that 2 as well. So if I think about this, I had x to the 3rd. I can definitely break x to the 3rd up into x squared times x, can't I? Well, that gives me an x times dx. Excuse me. So I have this x dx over here. All I do is get rid of that 2. So I have a half du is going to equal x dx. So my integrand becomes 1/2, or 1/2 times the integration of, I have that x squared. What do I have about x squared? X squared equals, u minus 1. So u minus 1 times u to the 5th du. I have my 1/2. I can go ahead and make this into polynomial looking form by multiplying my u to the 5th through. So I get u to the 6th minus u to the 5th du. Integration of u to the 6th is u to the 7th over 7. U to the 5th gives me u to the 6th over 6 plus c. Integration of, I'm going to replace my u's with x squared plus 1. So I have a half of x squared plus 1 to the 7th over 7 minus x squared plus 1 to the 6th over 6 plus c. Again, if we want, we could find a common denominator. We could factor out common factors out of the numerator. A lot of things that we could do, things that you're going to have to be able to find within the answer. And I'll leave that up to you on how we're going to do that. I have one last example here. Give us a little more practice with it. Here on my u, what am I going to let my u equal? We could let u equal the numerator. We could let it equal the entire denominator. We could also look at just this part of our denominator. And that's kind of the way I'm going to run this problem. Because as I look at this, and hopefully you're starting to look at it as well, this x minus 1 can be written as a negative exponent, can it? So now we have a quantity times a quantity to an exponent. And what do we let u be but, yes, that quantity that's to an exponent. So du then is going to equal dx, and we're back to this problem again, where we have x's left, and we got to get x's out of here in terms of u. So we know that u plus 1 is going to equal x. So what does my integrand look like? Well, we're going to have that 3, the x becomes u plus 1, minus our 2, times x minus 1 is our u to the negative 1/2 du. We're going to go ahead and multiply this 3 through and clean it up, so that gives us 3u plus 3 minus 2 there. So I get the quantity of 3u plus 1 times u to the negative 1/2 du that we're integrating. Go ahead and multiply your u to the negative 1/2 through, and that gives us 3u to the 1/2 plus u to the negative 1/2 du. We can go ahead and integrate. We have 3u. This is going to become u to the 3/2. We're going to divide by 3/2. That's the same as multiplying by 2/3, isn't it? So 2/3 times 3 gives us 2. If you don't like doing all of that in one step, by all means, step it out. So we would have 3u to the 3/2 divided by 3/2, multiplied by the reciprocal, and that's where we get our 2. To that we're going to add u to the 1/2, divided by 1/2 is again same as multiplying by 2, plus our c value. Replace our u with x minus 1, and we're going to go ahead and get our answer that we're looking for. Again, we could go ahead and factor that if we want. We could factor out an x minus 1 and a 2. I don't know if it's necessarily needed, but we're definitely going to go ahead and do it just because I feel like doing it and I have a little extra time. So we have x minus 1 left over here. Then here I take a 2 times x minus 1 to the 1/2. I take that all out, so I get a plus 1. Well, that's kind of nice because in here, that's going to all clean up. So it's actually kind of neat that I did that. Negative 1 plus 1, those cancel. So we get 2x times x minus 1 to the 1/2 plus c. So not necessarily that I knew that was going to clean up that nice and cleanly, but something that definitely you're going to see this answer as a multiple choice much more than you're going to see this as a multiple choice answer. Not necessarily that you're going to have to, but it's probably going to be that way. So that gives you an idea of some more complex integrations by substitution, where we have to go back and solve for x and plug some things back in, or do some more substitution within our integrand. By all means, if you have questions, let me know. Good luck, enjoy, and happy integrating.